Okay, looking at our do now. Our do now is the beginning of our lesson for today. It says, imagine you have two equally sized containers. One is pure water and the other is 50% juice. If you combine them, what percent juice would be the result? So this is kind of what we're thinking about when you have a container of orange juice. If you actually look in the ingredients, you're going to find that water is usually the first ingredient in there. So there's actually more water than there is anything else. So in this particular situation, we have two different sets of liquids, in two equally sized containers. One of them is pure water, and the other is 50% water and 50% juice. So when we look at this, and we have this table here to set up, we're not given any values here. So generally, it would be to make it out of 100. And there are really just some checks here. And so we're not looking for percentages here, we're looking for the amount in gallons. So I'm just going to say that to start that my first liquid, which is the pure water, has 100 gallons, and the second liquid also has 100 gallons. So the amount of pure juice in the first one, well, it's pure water, so that would be nothing. And then the amount of water is going to be 100. So the total amount of liquid is 100. So that's really just our check down there at the bottom. These two things do add up to equal that. And that's also going to be kind of an important concept as we move forward, when we're going to be able to write equations to help these out. So looking at this, for this, now this one is percent times whole, so we know there's supposed to be 100, and there's 50% juice, so that's our quantity is going to be 50% of the 100, or 0.5 times 100, which is equal to 50. And moving on to the next one, we have 50%, 50% juice, and 50% water. So this one's actually going to be the same, 0.5 times the 100 is going to give me 50. So when we're looking at our total amounts of liquid in our resulting liquid, we're going to be adding across here, and we'll get 200 gallons in total. And 100 plus 50 of that is water, so 150 gallons of water, and 0 plus 50 of that is the pure juice, so 50 of water. What percent of the total juice would be the result? So what percent of the total is juice? So this is 200. Q is equal to percent times whole. Our whole is the total amount of juice, which is 200, and we have a quantity of 50 gallons of juice, so our percent divide is going to give me 0.25, or 25%. Alright, so the next one, it's a little bit more clear, where you have 2 gallons of pure juice, so 2 gallons in our first liquid and 3 gallons of our second liquid. Try and go ahead and fill out the rest of this table on your own, and see if you can't figure everything out. Remember that these are kind of percentage of wholes, and then we can add across to get our resulting liquids. So one thing that's the easiest one to fill in here is the fact that this is going to be a total of 5 gallons of liquids. It says what percent of the mixture is pure juice. So we're really trying to figure out this number up here. But as we follow through, the first one is a 2-gallon container that is pure juice. So that's going to be 100% juice. So this is going to be a 2, and there's no water. The second one is just pure water. So there's no juice and 3 gallons of water. So our resulting liquid has 2 gallons, and really that's enough to figure out what we need. But as a quick check, everything does add up, so that does kind of help us check by going through all that information. So again, Q is equal to percent times whole. We're looking for the percentage of the total that is juice, so 2. And when we go ahead and solve that, that's going to give me 0.4, or 40%. Alright, looking over here, it says a 2-gallon container is a juice mixture 40% juice, 3 gallons of water? What is the percent mixture of the juice? So again, we're trying to figure out, we really need to figure out this one and this one. See if you can't fill out the table on your own. So first one is a 2-gallon juice mixture. The second one is 40% is 40% juice. The second one is a 3-gallon mixture. So 40% is juice. So 0.4 of the 2 gallons is juice. And that means, it's going to be 0.8. Which we can subtract to find out, or we can say, 60% must be the water. It doesn't really matter which way you think about it. Either way, we're going to get that this is 1.2 of water. The second 3-gallon is pure water. So when we look at this, this is going to be 3 gallons and that. So it's going to be 0.8, because 0.8 plus 0, so there's a total of 0.8 gallons. 1.2 gallons of water and the 3 gallons of water is going to give me 4.2 gallons of water and a total of 5 gallons. And that all adds up, so that's my quick check. 8.8 and 4.2, so I'm looking for the percent that is juice. Q is equal to percent times whole. Our whole is 5 gallons. Our quantity is 0.8 gallons of juice. Divide by 5, divide by 5. And that should give us 0.16 or 16%. And the last one, try and go ahead and set this one up all on your own. All right, so our first liquid is 2 gallons. It is 0.4 times 2. 40% of that 2 gallons is juice. That's 0.8, which leaves us 1.2 is water. When we look at the next one, it's added to 3 gallons of pure juice. So this is 3 gallons and it's all juice and no water, which means that we have a total of 3.8 gallons of juice and 1.2 gallons of water and a total of 5 gallons. So when we look at this, Q is equal to percent times whole. We're looking at our quantity of juice. 3.8 is equal to what percent of 5? And we divide by 5, and that gives me 0.76 or 76% juice. Okay, so let's go ahead and move on and look at our aim for today. We've actually already gotten started on it. All right, today's aim, Kipsters will be able to use a table and write equations to solve mixture problems. Mixture, M-I-X-T-U-R-E, mixture problems. All right, so we've already seen a bunch of mixture problems and we use the table to do that. So we now have a 5-gallon container of trail mix. It's 20% nuts and the rest of it must be other. So in order to help us write an equation, we're going to use the relationship that we've had in the table. So I'm going to start by creating my table And so in my first column, that's going to be my labels, 3 rows. So this first one is talking about, 4 rows. This is going to be my nuts. This is going to be my other stuff. This is going to be my total. This is mixture 1. This will be mixture 2. And this will be my total. All right, so in our nuts, our first one says a 5-gallon container of trail mix is 20% nuts. So our first mixture is a 5-gallon container that is 20% nuts. And our second mixture, we actually don't know anything about. That's actually what we're trying to figure out. Our last container, or what our total is 12-gallon container that is 40% nuts. So we know that 40% or 0.4 of the 12 is supposed to be nuts, which is going to give me 4.8 gallons of nuts, which means 60% or 0.6 times 12 or 7.2 gallons is the other stuff. So when we're looking at this, we know that we need to have a total of 4.8 gallons. We know this plus this is supposed to be equal to this. Well, we know 20% of this is actually nuts, so 0.2 times 5 is going to give me 1 gallon of nuts. And so really our equation is 1 plus, this is our unknown, in order to kind of help us figure this out, we could say 1 plus x is equal to 4.8. We could also say 5 plus this unknown y is equal to 12. Well, we know that's actually just going to be 7. We really don't have to solve an equation for that one. And you know, this is going to be, all right, so this is 1 plus 5. 1 plus 4 is 5. Moving down, and this would be, well, we can't really figure this one out, so it would be 7 minus x. So 7 minus whatever is nuts is going to be other here. So a couple different ways we can write the equation. There's plenty of different ways to go through this. I feel like this is probably the easiest equation, but we could also have x plus 7 minus x is 7. That actually doesn't help us out. But this one over here, it could be 4 plus 7 minus x is equal to 7.2. All of these things could be usable here. So explain in words how each part relates to the situation. So realistically, we've done that within our table. So 12 is our total size of mixture. That makes 5 our size of mixture 1. And we'll go ahead, and this 1 represents the 20% of nuts in mixture 1. And this 4.8 represents the 40% of nuts in total mixture. What percent of the second trail mix is nuts? So a couple different ways. Again, if we're looking for this, this is going to be, we're looking at this column here for our second mixture, and we're looking for percent of Q is equal to percent times whole, where our whole is 7 gallons and X is our quantity, and we're trying to find the percent. So we have to find x first. So we're going to use this equation up here. 1 plus x is equal to 4.8. I actually add a -1 to both sides. And I get x is equal to 3.8. So 3.8 gallons of nuts is what percent of the 7 gallons of nuts? And we go ahead and do that division, and we're going to end up rounding this response. Our percent is approximately 0.543, or that would be 54.3%. So you can see when we set up our table, we can use the relationships inside that table to write equations that can help us find the different pieces that are missing in the table. All right, so it says represent each situation using equations, show all steps. So we're going to make a table for each of these particular problems, and hopefully you should be able to do that on your own at this point. Note that if it only gives you one part of the mixture, that you'll just call the other part other. So just looking at this first one as I set up my table, 1, 2, 3, 4. 1, 2, 4. This first one, mixture is 25% oil. That means that it's going to be 75% other stuff. And this is our total. And so this will be mixture 1, mixture 2, and our total. Go ahead and finish filling out this table and create a table for all of them to solve for the question that's being asked. So I think the hardest part is going to be the figuring out what exactly is being asked of me. So I think really focus in on each of those questions. All right, so as we begin to fill this one out, we have a 6-pint mixture. So 6 pints is added to a 3-pint mixture, which means we're going to get a total mixture that is 9 pints. The first one is 25% oil, 0.25 times 6. That's going to give me 1.5 pints of it is oil. And the second one, which means the rest of it's actually going to be 4.5, doing some subtraction, or 0.75. The next one is going to be 0.4 times 3, 0.4, 40% of the 3 gallons. That's going to give me 1.2, which means 1.8 is going to be the other stuff. So we get a total of 1.5 plus 1.2 is 2.7. 4.5 plus 1.8 is 6.3. And we can see, just as our quick check, like this does add up to 9, this does add up to 6, this does add up to 3, so everything in our chart looks good. And the question is asking what percent of the mixture is oil. So percent of this final mixture is oil. Q is equal to percent times whole. Whole is 9, quantity is 2.7. Looking for our percent, throw that into the calculator, and we should get 2.7 divided by 9 is equal to exactly 0.3. 0.3 is equal to our percent. Move the decimal 2 times, that's 30%. Looking at the next one, you should have already done. If you haven't, please stop and do that now. We set up our table. All right, so we're looking at gold chains. One of them is pure gold, so we're having gold and other stuff. And a total. We have mixture 1, so it's a mixture of gold and other stuff. Mixture 2, of gold and other stuff, and our total amounts of each part and our total. First one says an 11 ounce gold chain that is 24% gold. All right, so this is going to be 11 times 0.24, 2.64. Our total amount here was 11. 11 minus 2.64 would tell me that this is 8.36 of other stuff. Mixture 2 is 4 ounces. That means we're going to have a total of 15 ounces of stuff. And 50% of that is gold. Actually, that one's one we can calculate in our head. 2 ounces of that, which means 2 ounces is going to be other stuff. That gives me a total of 4.64 ounces of gold, 10.36 ounces of other stuff. What percent of the locket is pure gold? So we're looking for Q is equal to percent times whole. Our whole for our total put together here is going to be 15. The gold portion of it is 4.64. So we can throw that into the calculator or just calculate it on our own. And that's going to give me approximately 0.309, which would be 30.9%. And finally, we have in a science lab, we have 2 containers that are filled with mixtures. The first container is 30% acid. Second container is 50% acid. So we've got some acid and some other stuff. So as we set up our table, we have our amount of acid, we have our amount of other stuff, and we have our totals, and we have mixture 1, we have mixture 2, and we have our total. So looking at this, we have our acid. This is 50% of this first container is 30% acid. It actually doesn't tell me how much it is. The second container is 50% acid, and the second one is 50% larger than the first. So this is where things are going to get a little bit more complicated. So we don't know the size of mixture 1, but we do know that it is going to be 50% larger. So since we're being asked what percent, we're not asking for actual amounts. We can actually just pick values here. So I'm going to do just what we normally do is I'm going to pick for mixture 1. I'm going to say the total is 100%. The second container is 50% larger, so that's going to be 1.5 times the 100, and it's going to make sense that this is going to be 50% larger. It's going to be 150. Which means we'd have a total of 250. And 30% of the first one is acid, so 0.3 times 100 is going to be 30. Second one is 50%, so half of that is going to be 75. We'd have 70 of other stuff, 75 of other stuff here. This would be a total of 105, and a total of should be 145. Q is equal to percent times whole. And what we're looking for, our whole was 250. Our quantity of just acid is 105. Divide by 250, divide by 250. And that's going to tell me that my percent is 0.42 or 42%. All right, let's flip on over and look at the next part. Okay, so this next one's going to be a little bit more tricky. So we're going to kind of help walk through this one together. You're going to be asked to kind of think several times along the way. So we're going to set this up. We've got containers that are soil, and some of that soil is clay, some of it is other stuff. So clay and other stuff. Total. And for this one, we'll have mixture 1, mixture 2. You can think about that as soil 1 and soil 2, and our totals. All right, so we have to kind of climb through the information that we have. 30% clay is added to the soil, and it's the first mixture, but it actually doesn't tell me what the total is. The second one contains 70% clay and is 10 gallons. So this one's 10 gallons, 70% of it is clay, so 0.7 times 10. This first one has 7 gallons of clay. That means it must have 3 gallons of other stuff. Oh, sorry, it actually doesn't tell us. Let's erase that. It once again does not tell us how much is in the second soil, but it creates a 10-gallon soil that is 50% clay. So in our total, half of it, 50%, is clay, half of it is other stuff. How much of each soil was combined? So what we don't know here is how much of each of these soils we have. So what we have to do here is we have to start thinking critically. So I don't know what the values are, but it's asking me how much of the soils are. So I'm not looking for a percentage, and I'm given some information over here about how much of each that I'm supposed to have. So I can't just make up numbers here. Since not everything's in percents, and we do have some information about actual values, we cannot just throw stuff in. So with this, we're going to say that mixture 1 is going to be X. And if I want to find out what mixture 2 is, I know that mixture 2 would be, so X plus this unknown would be equal to 10. Or if we think about that, this is going to be 10 minus X. That's how I can find what's left over. So as we look at this, we know that 30% of this one, so 30%, if we're thinking about percent times whole, this one is going to be 0.3 times the whole thing is X. So this is 0.3X, and mixture 2 is going to be 0.7, and the total there is 10 minus X. And we know that that's supposed to add up to equal 5. And so that's actually the equation that we can use to solve this. This is 0.3x plus 0.7 times 10 minus x is equal to 5. And so if we look through this, we definitely have to do some distribution here. That's going to give me 0.3x plus 7 plus negative 0.7x is equal to 5. I'm going to go ahead and combine my like terms here. That gives me negative 0.4x plus 7 is equal to 5. Now go ahead and start doing some inverse operations. Negative 0.4x plus 7 plus negative 7 is equal to 5 plus negative 7. Negative 0.4x is equal to negative 2 divided by negative 0.4. That gives me x is equal to 5 gallons. So now that we know that there are 5 gallons of this, let's start filling this in. There are 5 gallons of this. That means if we have 10 gallons, there's 5 gallons of second mixture. We can go through and quickly check on this to make sure that everything adds up. So 5 times 0.3 is going to give me 1.5. 5 times 0.7 is going to give me 3.5. And that's going to give me 3.5 and 1.5 left over. And we can see that everything adds up. Our 1.5 plus our 3.5 gives us 5. Our 3.5 plus our 1.5 gives us 5. The 5 plus 5 gives me 10. And so how much of each soil do we need? Well, we need 5 gallons of each soil. So as we come over here, we're given an equation, and it tells us it's used to model the mixture problem. So when we think about this, how many units are in the total mixture? So looking at our total mixture over here, this would be our total part. It's 0.4 times 6. So actually what it's telling us here is that our total mixture is going to be 6 gallons, and it's going to be 40% of whatever we're looking for. Just call it stuff 1. So what percent relate to the two solutions that are combined? So we can see over here, here we have our 0.2, so that means 20% of stuff 1. And mix 1. And this one is going to be 0.8 or 80% of stuff 1 and mix 2. The two solutions combine to make 6 units of what percent solution? So really this is just asking us to solve this. So I'm actually going to come solve this down here where I've got a little bit more space to do it. Starting with my distribution 0.8 times x, I'm going to get, this is the distributed version, 0.2x plus 4.8 plus negative 0.8x is equal to 6. Not 6, it is 0.4 times 6, that's going to be 2.4. So combining like terms, this is going to give me negative 0.6x plus 4.8 is equal to 2.4 plus negative 4.8 is going to give me negative 0.6x is equal to 2.4, negative 2.4, negative 0.6 divided by negative 0.6, it's going to give me x is equal to 4. So going all the way back to this, this tells me that the total size of the first is 4. So actually this is probably helpful to go ahead and set up the table here in this space. We'll just call this stuff 1, stuff 2, total, this is mix 1, mix 2. So that gave me the x for this one. tells me that mix 1 is 4. That means mix 2 is going to be 2. We know that stuff 1 is 2.4 in the total. The two solutions make 6 units of what percent solution? So this is going to be 2.4 of the 6. So Q is equal to percent times whole. Our solution has a total of 2.4. And so when we go ahead and calculate that out, we get 0.4. When the amount of resulting solution is given, for instance, 4 gallons, but the amounts of mixture solutions unknowns, how are mixing the solutions represented? So when we see this, how are the amounts? It's going to be X and total minus X. So we can see that here in this example that we did over here, where we started with the amount for the first one was X, the second one was 10 minus X, and for this one over here, it was the same story. We had X and we had 6 minus X. All right, go ahead and flip on over and finish up your alone time.